In this video, we'll look at the factor theorem. So, the factor theorem states that if we have a factor such as x take k, then k must be a 0 of p of x. This symbol here means it works both ways. So, if we have a 0, we know that that gives us a factor, and likewise a factor gives us a 0. In this question, we have x take 2 is a factor of our cubic, and we need to use that to fully factorize that cubic. Two techniques. First technique is my least preferred technique, which is using the remainder theorem. So, if I have x take 2 is a factor, that means there's no remainder, so p of 2 equals 0. That's the remainder theorem. So p of 2 I can work out by substituting 2 in place of x in my cubic. So 2 cubed is 8, k times by 2 squared is 4k, minus 3 times 2, plus 6 equals 0. Rearrange, I'll get 4k equals negative 8, and therefore k must equal negative 2. So now I can replace k by negative 2 in my cubic, so let's call it p of x. And that equals x cubed minus 2x cubed, etc. 2x squared, sorry. Right, and that will have a factor of x take 2, and there must be some other quadratic factor. So that quadratic factor will be x squared, as x squared times x makes the x cubed term. And the constant term must multiply with negative 2 to make 6, therefore has to be negative 3. The x term I'm not sure about, let's call it bx, making sure that b hasn't been used elsewhere in the question, and it hasn't. Now if I expand and equate, I can find b, but rather than expand the whole thing, just work out the coefficient of, say, x squared. So to get an x squared, I could do my x times by x, or x squared times by constant. So there's my x times x term, and x squared times constant, and that must equal the minus 2 in my polynomial. Solve that, I get b equals 0. So now I can rewrite p of x as two factors, x take 2 and x squared take 3, and this will factorize further. That quadratic is the difference of two squares. So the x take 2, and then x plus root 3, and x take root 3. So now we've factorized our polynomial. Second technique involves using synthetic division. The reason I like this is because when I divide synthetically, I end up with the pattern for the quadratic factor that's left behind. So dividing synthetically, we take the 0 from the factor 2 and divide it into the cubic, making sure that we don't have any place value missing. So we've got each term there from cube down to constant term. I'll put a 0 down first, add the columns, multiply by 2, add new columns, and multiply again, add up these two, then multiply that by 2. And when we add these two last terms, what we end up with is the remainder, which in this case equals 0. So 4k plus 8 must equal 0. And if I solve that, I'll get k equals negative 2, as we did previously. The good thing here, however, is now I'm left with my quadratic factor. There it is there. And I can replace k equals negative 2 to get that factor. So p of x was equal to x take 2. Then my quadratic will be x squared. We have a 1 here. If I replace k equals negative 2 in here, I end up with 0 for my x coefficient. And my constant term, I'll get 2 times negative 2 plus 1, which is negative 3. And that's the pair of factors we had previously, which becomes 3 linear factors as seen before. That is enough to get you working on exercise 2F.